Welcome back, everyone. So, in today's lesson, we will be discussing one of the most important pillars of AWS Well Architected Framework, and we are going to talk about security pillar. It is one of my favorite subjects, and also I have worked in many folds on this particular pillars, and I would like to run you through some of the design principles which from the cloud practitioner exam perspective could be some questions might be there, but we are not going to implement any of its features because the cloud practitioner exam is just the foundational exam. But you need to understand how you are actually designing a solution or a solution what you are providing to your company. It could be your end-to-end solution. It could be your infrastructure solution with respect to security, or it could be anything with respect to security. So the first design principle is of least privilege. Least privilege means like just we need to give privilege in the need to know basis. Like if I want a read access to a database, for example, to see what are the populated tables and other things, I should not have write access there. Write access means that I am able to modify the database. I am able to modify the records. Even I will give you a small bit of introduction to tokenization. For example, let's say a multinational bank which also takes care of credit cards and other sensitive information. For example, the email address, the physical home address of the customer and other things. So let's say like I am an administrator of the database. Do I need to have view access or do I need to be able to see their credit card number? No, I should not. And why I should not? Because I am a DB admin. I have to keep the database up and running, right? Why should I have access to their credit card numbers or their home address and other things? So that is where the principle of least privilege comes in, right? Where we use the technology called tokenization, where only the authorized person is able to view the data of that particular table contents, right? Or that particular column. So if somebody calls to our customer care, to the multinational bank's customer care, that I have some transaction issue in the credit card. So even though the credit card personal has the access to particular DB to see the credit card numbers, he or she should be able to see only the last four digit. Does the customer care professional need to know all full credit card number? No. So that is what is called least privilege. Then we have, enforce separation of duties. Enforce separation of duties means it is actually, not feasible to separate the duties because in a bank where you have run the bank team and other things, yes, we have different shifts, different rotas and other things. But separation of duties means the run the bank team cannot do or change the bank. But how it can be enforced is through mandatory leaves. For example, there should not be a dependency on a person or a team who is taking care of the end-to-end operations of, let's say, the credit card thing. So the mandatory leaves allows to understand whether that particular person has least privilege or whether that person actually has so much dependency that if he leaves the organization or if or he or she actually is not in the organization due to some reason. It could be holiday, or it could be your annual leaves, or it could be any reason, whether the day-to-day business as usual operations can go in, right? So that is the first design principle of AWS Well Architected Framework for security pillar. We come to the next one, traceability. Traceability is by default should be everywhere in every step, right? Why traceability? Because traceability will give us ownership, like who did what and when. So in AWS, we have, for example, CloudTrail, we have CloudWatch, we have many other operational monitoring capabilities where we can understand and learn like what happened to this particular service, why it was down. Was it a manual shutdown, or it went down by default due to some, let's say, over memory utilization or over CPU utilization, all these things. Also, there is a norm, like from in terms of compliance and other things, like many uh, financial institutes, right? They have a norm from the regulator that all the logs, all the, audit logs and other things, it needs to be kept for at least 7 years plus plus. Many other multinational financial institutes have their own criterias with respect to regulators. Some have 7 years, some have 3 years. Where do you archive all these things for traceability? So here comes the feature of AWS S3 Glacier and other things which we can utilize, right? Moving on, applying security at all layers. It is also apply a defense in depth approach, which means like what is the entry point to your AWS, right? We have actually seen in previous videos that we have a load balancer which is accessible to everyone in the world, right? Whenever a traffic hits the load balancer, this particular security should start from the very first touch point of your infra, your data center, your AWS VPC, or your any of the AWS resource which is being utilized for access to your resources. So first step, for example, could be your AWS load balancer. Who, which IP hit that particular load balancer at what time, and how secured it is, like whether it is HTTPS or is it just port 80 or port 443. So all these things, let's say after load balancer, it goes to EC2. Like, do the EC2 have that particular connection coming as encrypted or unencrypted, right? All these things, you have to have a view it from a security architecture purview. My connection should not be unencrypted unless the application needs to be accessing it unencrypted. For example, we cannot have a unencrypted connection coming in from application load balancer to the EC2. What if there is a man in the middle between the load balancer and the EC2, and he snoops all the initial things, what the things are coming in from the load balancer. Similarly, from let's say EC2 to database, all these things. This is a end-to-end, security of all the layers. Let's say from load balancer to EC2 to database, all these things, right? Then back, you need to send back the acknowledgement and all these things. So how do you make sure that this is all encrypted and all the security things are being placed at the right place? Okay. Automation is the best practices for security. For example, in many of the banks, in many of my previous organization where I've worked, We have pipelines for DevSecOps and other things, right? You deploy the things automatically. That is hands off. The more you are hands off, the more the first principle gets implemented. Least privilege, right? So it can be your, let's say, a flow starting from Jira to next steps with gated approvals to deploy a new thing with all the approvals, change managers, incident managers, all the things in place with all the approvals with security and risk management approvals and other things. Then we are going to deploy without any hands on or manual intervention thing, right? So automation is always the best practice, which actually fits in not only in security, in all the pillars which we will talk about in near future. This is always a yes, data in transit and data at rest. If your data is residing in S3, it has to be encrypted. That is data at rest. If the data is coming through ALB, it has to be encrypted because it is data in motion or transit, right? Keep people away from data. Data is the king. Like if you have access to the data, for example, we were talking about, right? The credit card numbers and other things, the user details, the user address. This is all sensitive data. And definitely it has to be tokenized if you are putting maximum security, where even the working professional who has to actually serve customers based on customers' request on credit cards and other things, he or she should not have also the full access to the credit card numbers, the payments and other things, the merchant's name to whom it was paid. It all can be tokenized. So you have to have a, you know, hat donned up as a security professional. And in every layer, every step, every access, every authorization has to be scrutinized and tested from time to time. That's why we have the last principle, design principle, prepare for security events. You have to have a mock drill. What happens if there is some breach? Whom to reach? What is the call tree number? What is the war room number? Who's gonna give the approvals for, let's say, a rollback or let's say a go ahead? All these things. So this is a bit of advanced thing which we were discussing. It doesn't come so much deep in cloud practitioner thing, but these are the courses and these are the discussions as a level 2 after you are done with cloud practitioner and you want to enhance your skill. These are the details which we will be discussing: how to face a security, let's say, architect interview, consultant interview. How do you prepare your CV as a security architect or security CV for any other position, right? Because you have so much to write in, and there are norms of writing a CV as a professional. You cannot be writing a 10-page CV, or you cannot be writing a like just 1-page CV also. Yes, we have to balance it, and that's all. That all the things we will do it in the level 2, level 3 courses. Thanks, and I'll see you again.